Hi, everyone. We'll just give it a few minutes for people to turn up. Oh, I see people in the chat. Lisa, have we lost you? Oh. Yay!
Hey. All right. I think we're ready to start then, everybody. Thank you so much for joining us today at our Go Static Image Learning Lab. I'm very happy to introduce Adrian, who is our staff developer relations engineer and who's going to be talking about the static Go image with Chainguard. And I also wanted to share that Adrian is also going to do a webinar tomorrow with two other engineers at Chainguard, and I'll drop the link in the chat. Awesome. So I'll hand it over to you then, Adrian.
No problem. Just a minor panic while I figured out where my slides were. Let me sort my screen out. And I'm making it more complicated. Okay, so hopefully everybody can see the slides. And now I've lost my notes. Here we go. Okay, so welcome to this Learning Lab session. Just to give some background, what we're going to be talking about is building secure and minimal images with Chainguard static images. And we'll primarily be using Go as the application, but the same technique should still be relevant for things like C and Rust, etc. It is a reasonably high-level talk. I won't be getting in deep down into details. The only real assumptions we're going to make is, a little bit about Docker, and that's about it, really. As long as you can do sort of Docker run, Docker build, you'll be fine. There is a practical, and that's probably most of this session, and you can follow along. And if you want to follow along, you'll need Docker installed, you'll need a text editor, and you'll need Git. So very simple and high level, and I'll share a link for the code in a minute. Okay, so let's make a start. Let's hope we can. Thank you, Lisa, for the introduction. Yeah, as she said, my name is Adrian Moat. I'm a technical community advocate, as I sometimes say, or DevRel at Chainguard. I've been working with containers for about a decade now. I think it's slightly longer, which is embarrassing. I did write a book called Using Docker a long time ago for O'Reilly, so I do have some experience in the space. If you do want to get in touch, feel free to drop me an email. You can also find me on all the various socials. It's usually fairly easy to find me because my surname is relatively unusual. So what are we going to go through today? So I'm going to start with this very brief introduction to what CVEs or vulnerabilities are, and then we're going to move on to talk about Chainguard and Chainguard images and how they help address the problem with CVEs. And from there, we'll jump into the practical, which is basically showing an example image and how to migrate it to a Chainguard equivalent. We'll go on to talk a little bit about multi-stage builds, how that gets us even further before wrapping up and talking about debugging and so on. Now, regarding questions, I believe you can ask questions in the chat. Please do so. I will try to stop and take questions at various points through the talk. Hopefully, Lisa will help me if I'm going too fast or I miss questions, etc. Please do let me know also if you're trying to follow along and you get left behind or stuck anywhere. Yeah, so as I said, if you want to follow along, you're going to need Docker. I think Podman and NerdCTL, etc., should be fine as well. To get the most out of the session, it would help you know a little bit about containers, but really just very high level, just how Docker run roughly works. And yeah, you'll also need Git installed if you want to get the example code and switch between the branches. But before going further, I want to take a step back and have a look at CVEs and talk about why CVEs are a problem for a lot of people and organizations. So CVEs stand for Common Vulnerabilities and Exposures. They're essentially known software flaws that have a security impact on applications. Now, some of these can be really significant. So you've probably heard of ones like Heartbleed and Log4Shell. Basically, if a CVE gets a name and not just a number, then you know it's probably had a pretty big impact. And CVEs basically led to the birth of a lot of security tooling like Trivy, Gripe, and Sneak. And all of these sort of tools will scan container images for known vulnerabilities and produce a report of what it finds in your container image. So ideally, as an organization, you would like to have a report that says your images are completely clean, like there are no known vulnerabilities in your image. But it turns out that's not so easy. And the reason it's not so easy is because lots of the base images themselves already have CVEs. So you're starting from a place where there already are CVEs. And this kind of left a lot of organizations a bit unsure of what to do. They want to get rid of the CVEs, but they don't really know where to start. And this is kind of where Chainguard comes in. So we call ourselves the safe source for open source. And we want you to be able to come to Chainguard whenever you need to use open source software in a secure and verifiable manner. So we've got over 100 customers across various industries, including heavily regulated industries such as defense and healthcare. But our primary product is Chainguard images. So these are minimal security hardened container images with zero known CVEs. So we're directly addressing the CVE issue that I mentioned a second ago. We've created over 1,200 images so far, all kind of directly in response to customer demand, so people asking for certain images. We build images daily, and we have images for all the various ecosystems, so things like Go, Python, Node, but also third-party open source, so things like Postgres, Nginx, Redis, and so on. For those of you that know what FIPS is, we do have FIPS images for certain, or FIPS variants for certain images, if you need to go for a FedRAMP or similar. This is a slightly old slide. I should have grabbed a new one, to be honest. But this shows the result of scanning the Chainguard Python image and the Docker official Python image with Gripe over the last sort of 30 days. And so the chart on the left here shows a Chainguard Python image, which has there's 1 day with a single medium vulnerability that you can see just around, what's that, the 5th of December. And the gray bars here are days for which we don't have data for whatever reason. And the chart on the right shows the Python image from the Docker Hub. So this is what you get if you Docker pull Python latest. And it has a lot more vulnerabilities. So you're looking at almost 200 vulnerabilities as of, 17th of December. So then the question becomes, why does the Chainguard image have less CVEs? And there's a few things. One, our images are very minimal. So we only include the packages and dependencies required to run the application. For production images, that typically includes removing the shell and the package manager. By having smaller images with less software, there's simply less software to have a CVE. But we're also constantly rebuilding from source. And this is honestly the major thing. So if an upstream project releases an update or a fix, and we'll typically get that on the same day and have an updated package and an updated image with that package in hours. And if you compare that to like a Debian project or the Alpine project, or an image based on the Debian or Alpine distributions, then you've got to wait for Debian or Alpine to create a new package with a new version of that software that contains the fix, which can take days or weeks. And then you've got to wait for Docker or whoever to rebuild an image that includes that version of the package, which again can be more days. So there's quite a sort of lead time on getting the fixes into your images in other situations. And we also investigate any found CVEs and issue security advisories as appropriate. So if we find a CVE as a false positive, we can flag it as such, and the scanners, your gripes and your trivies, your sneaks, your whizzes will pick up that security advisory and mark it as not impacted, and mark our images as not impacted. Okay, I'm going to switch to the practical now. So we are going to use a GitHub repo with some code in it. I wonder if I can change my tab here. So this is the GitHub repo. It's at learning-labs-static. So you can git clone this if you like, using whatever method you prefer. Do note that this repo has 3 separate branches. So that the main branch is default application that I'll show you in a second, but there's also a branch using a Chainguard image, and then there's a branch using a Chainguard multi-stage image, which will make more sense in a second. Okay, I'm going to switch to the terminal now. Is there any questions before I start? Oh, I see there's a question about debugging production images. I actually have a whole section on that later, so I'll take that later, if that's okay. But basically, there are debugging tools that I'll show you. I see Lisa's linked my using Docker book. Honestly, please don't buy that. If you want to go and look at it if you have access to the O'Reilly Safari, then please feel free to go and look at it. But don't go and buy it because it's out of date now. Yeah, and thanks, Lisa, for the troubleshooting. Link. Any other questions? No questions. Good. Right, I'm going to change to my terminal now, if I can figure out how to do that. Screen. Oops, just push Q&A by accident. Window. That looks like an iTerm. There we go. Okay, so I'm in this iTerm. How do I prove my Git branch? Git branch? When you -L? I can't remember. Oops, I just pushed around. I've also got a new keyboard, so I keep hitting the wrong keys. It's a good time to get a new keyboard. Yeah, so this is just a clean checkout. Well, I can do a reset, but it's a checkout of the repo I just showed you. So if we take a look at first we can take a look at the code. The code really isn't too interesting. We have this is the server file, which just calls app_run_server, an app_run_server. Type the wrong keys because I am struggling with this keyboard. And actually, what's the other one? Internal. And this is the entirety of the application. So all we're doing is starting a HTTP server that's going to return hello world when you access it. So extremely simple application. Excuse me. We can, you could build that with go build cmd server, but of course we have a Docker file. So let's take a look at this Docker file. All this Docker file does is it's from Golang. So this is the upstream, the Docker Hub official Golang image, which is based on Debian. All we're doing is copying our Go code and running go build, which is going to produce the CMD server output. Oh no, it's going to build CMD server and produce hello. I scared myself there. A binary called hello. And then it's going to set entry point to the path to that binary. So pretty simple. Let's check it works. Docker build, and what will we call it? Hashtag static learning lab. And I did try this earlier, so this will probably all be cached and very fast. Yes. So if you're following along, that might take a second longer because you'll have to. Yeah, it's all been cached on my machine, and you might need to download images, etc. But anyway, it's built fine. We can run it. I suppose I should run it in the background so you can see what it does. What did I call it? Static Learning Lab. We will need to open a port if you want to see what happens. So we'll have 8080, and we'll link that to port 8080 on the host. Move my terminal so I can see a little better. And now if I do curl, yep. So that's all it does. I'm going to remove this before it confuses me later. Yeah, you can see me struggling with my keyboard again. 17E7. Okay. Now, the problem with this image, if I do Docker image, well, there's a couple of problems. The first one is if I do Docker images, is it image or images? Static. Well, we can see it's 1.33 gigabytes, which is pretty large for this application. If I was to compile a binary, you'd find out, if I was to just look at the binary, you'd find out the binary is only about 10 megabytes in size. But yet we've got a 1.33 gigabyte image for this. The other thing, and frankly, the more worrying thing, is if I run Gripe on this image. So Gripe is a free open source security scanner. If I run Gripe on this image, it's going to tell me how many known CVEs are present. And all of these, in this case, are from the Golang Debian image rather than our application, remember. Which won't necessarily always be the case, but in this case it is. So it's found, what's that? Did I get up to 249 different packages? Yeah, so there's 249 packages installed in this image. And it says there's 243 vulnerabilities. So a lot. Most of them have been marked negligible, but there's still highs and mediums and criticals apparently down there. Typically, the ones that are marked won't fix are things that Debian have looked at and are not interested because they're probably not a true CVE that can impact people. There's also Docker Scout, which is another scanner that I quite like. We can take a look at that. And that will give you a slightly different number. So go from 243 that was found with Gripe. And this actually says there's more packages, 303. But this is saying there's only 59 vulnerabilities found. It's also suggesting that you change the Alpine image. Okay. Now so what can we do about this? So the simplest thing, or the thing we're going to try first, is just changing cgi.dev, change from Golang to cgr.dev chainguard/go. And we will write that. So I've only changed one line of code, and we can see what difference that makes. Call this static Chainguard Learning Lab. Okay, that's built quite quickly again because I had it cached. And just to prove it works, or at least it runs, I won't bother running it in the background. So that looks good. Now, if I do Docker images, this still has the whole, the Go compiler, the Wolfie operating system, and a whole bunch of other things inside the image. So it's still quite large. It's still 1.18 gigabytes, so maybe a couple of 100 megabytes smaller than the previous image, 150 megabytes smaller than the previous image, which is not nothing, but it's only a small percentage of the image overall. So the more interesting thing, however, is if I use gripe and have a look at this image. Now, I did try this earlier, so we do. So I do know what to expect here. So remember, gripe found 243 vulnerabilities, and we've gone down to 1. And it's marked not fixed here, and unknown severity. This same CVE, I did look it up, and this is present also in that Debian, the Golang image. It's related to Git. If you go and look into this vulnerability, you'll find there's not an upstream fix available yet. Also, if you are looking at any of our images, one thing you can do, I will share a different tab. Chainguard images, learning labs. Here we go. So one thing you can do is go to images.chainguarddev/security and search for CVEs. And of course, what was our number? 2024, so it always has the year and then a number. And you find a bit more about it and what's going on. So it still says under investigation. I did talk to the team earlier. The issue is basically there's not an upstream fix they can use yet. So as soon as that's available, we will, of course, pull it in and fix this CVE. Okay, let me go back to my terminal. So many buttons to click. Okay. Oh, I see some chat. Is there anything I should answer? Oh, that's a good question about, are we going into source code and fixing the vulnerabilities there? No, generally we won't do that. We'll be reliant on upstream fixes. So in this case, that's exactly what we're doing. We're waiting for the developers to agree on what the correct fix is. And once they've done that, they'll issue a patch. We'll pull in that patch and we'll address it. Probably the main exception to that is when a fix is bumping a dependency. So what you may find is a project, an open source project, has a CVE, but the CVE is coming from a dependency of that project. So, it's reliant on version 1.2 of some JSON parsing library, but version 1.3 has a fix for some CVE that isn't actually possibly even relevant to the project. So the project itself hasn't issued a update for that fix because they're just not interested. it's not really worth their time, or they haven't issued a new release with that fix. So what we might do then is bump the version ourselves, rebuild it, and fix that CVE for you. But no, generally we are not going into source code and fixing things ourselves. Oh, and Lisa's got a message there. The CVE system being what is it worth to chase a zero CVE fantasy? Well, I mean, you can go and check most of our images. Most of them are zero CVEs. So hopefully it's not a fantasy. URL for the CVE. So if you go to, well, maybe Lisa will help me out, but it's, well, actually I've got it. I'll give you this link. There you go. There's the URL that I was looking at a second ago. And I think it has a couple of links that'll take you to NVD and Git. Honestly, it's not a particularly interesting CVE, but it was to do with outputs and, yeah, terminal output. Anyway, okay, I'll go back to my demonstration. So we've got pretty far by just changing one line of code to be CGR, to be a Chainguard image. But we can take this a lot further. And one of the major things we can do, and some of you are probably aware of this technique, is use a multi-stage build. So the multi-stage build is basically going to be where you've got a second build step where we take the binary that we build in the first step and copy it into a new image. And the new image that we're going to use is called static. So I'm going to use a Chainguard static image. And I should say both this Chainguard Go image and this Chainguard static image, the latest versions of both of these are available free. So, you can follow along and do this and use it yourselves and so on. If you need like an older tagged version or a FIPS version or something, then I'm afraid that is a talk to sales thing. Anyway, we're going to call this, actually I should use capitals, our builder image. So this is our build step. And this is a production image based on static. So static's a very small image, has very little in it. One thing it does have is things like TLS certificates, which you need to talk securely to websites and so on. I think it's also got time zone data and a few other things. It's also got directories like /temp and /home, which are commonly needed by Unix utilities. So it's only a few megabytes in size, but contains a few things that are commonly needed by applications. And now we're going to do copy. And let's hope I get the syntax right. Is it -- from equals builder? So we're saying copy from the builder, which is our previous build step. And we're going to copy the /work /hello. And we're going to copy it to just /hello, I think. And then we can set the entry point. And that's going to be a / oops, see, still struggling with this keyboard /hello. Oh, there's one more thing I need to do. I need to tell Go to create a static binary. So normally it will create a binary that's dependent on at least sort of glibc and other libraries, but you can tell it to create a completely static binary. Now, how you do that is slightly dependent on, it's slightly dependent on exactly what libraries you're using within your image. In this case, it's enough to pass cgo enabled equals 0. And that will create a static binary in this case. In other cases, there may be some other flags you need to pass. I do link a resource at the end of these slides, which you can go and check out and goes into details about exactly what flags you can pass to get Go static binaries. But in this case, this will work. And it's just a bit of background. It is sort of generally dependent on which kernel calls there are Go equivalents of. So basically, this is saying, hey, use the Go equivalent kernel calls when possible and don't call it to glibc. Don't worry if that's, don't worry. I realize it's quite technical thing. Don't worry about it too much. Just know that this is going to create a static binary that's not dependent on external libraries. Okay, so if I've got this right, which is not guaranteed, we should be able to do docker build. And we'll call it multi-stage this time. I'm not sure if this will be cache or not. Oh, it was cache, so I guess it worked the same as it did in my test. And that makes me hopeful that static CGMS Learning Lab. I should give it a port. HP. I think that's how it would work, but I'll do it better. I think that'll work. Okay, so that we built that, that works. Just to prove it is running that one, there's two things running. And did I not start that one? Okay. Oh, look. Yeah, this one is on port 8080 on my host. The other one, I have an old container on a different port just to prove I'm not connected to that. I will remove it and avoid any confusion. So this is an old unrelated container, and this should still work. Yeah, okay. But the really nice thing, if I do Docker images, static, what was it? I've forgotten the name. Static Chainguard multi-stage Learning Lab. Well, it's only 15.4 megabytes. So finally, we've gone from this like gigabyte-sized image down to just 15.4 megabytes. So that's just the application we need, plus a few other things in the image that total about, I don't know, 5 megabytes. So absolutely enormous saving on space. But the more important thing, if I type gripe on this, this doesn't have Git. This image no longer has Git in it. So I am hopeful that if I run gripe static Chainguard msll, and this should also scan much quicker because there's just less in it. Note it is picking up packages and executable, but it finds no vulnerabilities. So finally, we've got to 0 vulnerabilities and a much, much smaller binary. Okay, I'm going to switch back to my slides and take the questions. Actually, maybe I should check the questions in case there's anything interesting. Do any of the static images have any of the Department of Defense CA certificates? That's probably a good question. I don't know 100% this answer. I doubt they're in the default images. Possibly they're in FIPS images or something. I'm not sure. But we do have a tool called Insert, and that allows you to put more certificates into images fairly easily. Or you can do it yourself. I mean, it's not yeah, it's fairly straightforward. Oh, somebody's already passed Insert. Thank you, Mike. What kind of returns? Reissue a production image because I'm not 100% sure it's been asked. Are you asking, like, are there problems with migrating to Chainguard because we have different packages? I mean, it depends exactly what you mean there. So we'll get to more details later. Just to be clear, like we are all based on glibc and compiled from source. So we should match like packages from Debian fairly closely or other repos fairly closely. I'm not going to say it's never production issues. You certainly do need to test things, and there is some time spent migrating, but honestly, it should be fairly fast. But yeah, it's a case of try it and see what happens. If you're using an image that's just going from Nginx to our Nginx image, that should be very straightforward, or Redis or database and so on. If you're building your application like a microservice on top of something else, yeah, it's going to depend on how many dependencies you have and what they are exactly. So it's very dependent, but in general, of course, we'll work with you and make sure we get things working. Do you have image for Tomcat? Yes, we do. And thank you, Lisa, for linking that. Any configuration set in Gripe to avoid false positives. So Gripe will automatically pick up our security advisories. So it will not have false positives in the output there. I guess what you're talking about with false positives is also like the things that we saw in Debian that were marked as won't fix. You can filter those out. And I probably generally recommend that. You can also probably filter out negligible, for example. But yeah, there shouldn't be false positives because we can, or any Linux distribution can issue a security advisory to remove that. So it might be temporarily a false positive until it's fixed. Any reason why Gripe not Trivy? Yeah, you can definitely use Trivy. I'm not sure I've got installed. For some reason, we use Gripe pretty heavily within Chainguard. I think it generally finds more things, but do I have Trivy? It looks like I do have Trivy. What's that? How do we run it? Let's see what it makes of Chainguard cgr.dev. Chainguard. This might be an old version of Trivy. Go. But yeah, absolutely, you can use Trivy. Not going to knock Trivy at all. Yeah, and there you go. There's a Chainguard Go image, and you can see a difference there. So that's found no CVEs, but the Gripe scanner did find one CVE in this image. Okay, I'm going to go back to slides for a moment now. Not that one, not that one, not that one. There we go. So here's what we did, and basically what happened is we first used the Golang image from Docker Hub, which was 1.3 gigabytes, or resulted in 1.3 gigabytes image, with 243 CVEs according to Gripe, or 59 according to Scout. I then moved to just a Chainguard Go image, which was slightly smaller, and only one CV according to Gripe. I don't think I ran it for you, but I did run Scout earlier, which turned up with 0 CVEs. And then we finally moved to Chainguard Static, which finally got us down to a reasonable size of only 15.4 megabytes, and finally 0 CVEs across the board. So that was a pretty huge win. But do note, like, even just changing that one line saved us a lot of CVEs. And it is worth pointing out that, the vast majority of these 243 CVEs probably aren't going to be problematic for you. But the issue is, how do you know? Like, are you going to go through all 243 of those and look at them and try and figure out if they can harm you or not? Because, you can just change your image and get rid of them, which is much easier than worrying about whether or not there is something in there that can harm you. Okay, so I've talked about static a lot, but what does it mean? So you can have static or dynamic binaries. Basically, a dynamic binary links against other libraries, most commonly system libraries. Static binaries, in contrast, are fully self-contained. So they have all the libraries they need to run and don't link out to any other libraries. Dynamic libraries are, a fantastic thing, because especially in the early days of Linux, where you didn't want to download you didn't want multiple versions of libraries on your system, because if you have fully static binaries and you got 20 different executables, they probably all contain the same library in there. So you can save that space by having a dynamic library. Rust and Go code itself is statically linked. So if you compile a Rust program, it is actually statically linked sort of within itself, except for the system libraries, and I think possibly for external libraries. Oh, sorry, foreign libraries. I'm not sure how that works. Yeah. Now, there's two common standard libraries in Linux. There's glibc and muzzle, or muzzle. glibc is sort of the standard library. It's used very widely, and it isn't very good for static linking, as in it's difficult to link against glibc and produce a completely static binary. We have variant images that I'll show you in a minute that do include glibc. Muzzle is an alternative C library and is quite often used when creating static libraries and things like C and Rust. So it's easily to create a static binary when using Muzzle. Sometimes there are compatibility and performance concerns with Muzzle. I don't really, you can find all the issues and debates online. There are arguments on both sides. But yeah, so sometimes you have a sort of almost static binary, if you like. It's static apart from a few common libraries, so things like glibc and OpenSSL or similar. And so we have a few sort of images that support you in those cases. So there's CC Dynamic, which includes libgcc, and glibc Dynamic, which includes libstandard C++, for example. I should also mention FIPS. So if you're interested in FIPS, I have not talked about FIPS at all in this lab, and you will need to take a slightly different approach. You are very much responsible yourself for taking care of making sure you get things right when creating a FIPS compliant binary. And we do have a Go FIPS image, and if you go and look up the overview for that FIPS image, it does give you some advice on how to create FIPS compliant images. And there's also a glibc OpenSSL FIPS image that I should say both of these are commercial images. There's a glibc OpenSSL FIPS image that you can use as a base as well. So you could use the Go FIPS image to create a binary that runs on a glibc OpenSSL FIPS. And if you do it correctly, you will end up with a FIPS compliant image. But yeah, please check your work. I see there's a few questions. Let me just check that. I think stuff in Q&A. Sorry if I've missed stuff there. Oh no, it's not. I'll take it back. Okay. What are the benefits of static over Scratch or something like that? That's a good question. Yeah, it's just that Linux binaries quite often expect a few things, or Linux applications expect a few things to be available. For example, like a temp directory. Like a lot of things expect to be able to call make temp, and you won't be able to if you don't have a temp directory. And also /home, also TLS certificates. So there's just a few things that you typically need in a base image that won't be present in the Scratch image. Scratch image is completely and utterly empty. Yeah, you can try it out and see what happens. It's quite a fun experiment. Can you attach the run image inside the container? So that goes back to the debugging thing that I had earlier. I'm going to show you an example in a minute. Oh, we're getting on. Are your images based off the same OS as the original Docker Hub? No, we used Wolfie, which is why we can issue security advisories, because we have our own Linux distribution called Wolfie. But like Debian, we are based on glibc. You think great? Yeah, CPU matching. Yeah, That's right. There is Gripe does do basically regexes, which sometimes go wrong. Basically, yeah. Just try the different scanners and see what you get and which results you like. I would point out that Gripe is the only one that found that Git vulnerability, which is, arguably present. I don't think it's anything to worry about, but it's there. Yeah. Share video. So the image stuff. Yeah, a lot of issues about fiction CVEs, I think. You've got CSV, but I think you mean CVEs. Yeah. So you can totally use the bash image and copy over the kubectl binary. I think it probably is what I'd recommend. Can all Vun scan tools scan static binaries? That's an interesting one as well. So there's a few things like these scanners do. The number one source of information is the package manager. So they will go into an image and they will ask APK, they will ask Yum, or whatever your package manager is, what packages are installed. And that's their primary source of information. Now, some smarter ones will also go and look for executables. So in the case of our Go image, Gripe will go and say, hey, there's a Go executable here, and it can actually look into that Go executable, and if it's still got the metadata, it will figure out which libraries it's linked against. And so it will have some information there. And so if we were using out-of-date dependency, it may pick up, hey, you're using a dependency with a CVE there. So that depends on which scanner you use. All the scanners are not equal, and I do recommend you look into what they do. Okay, static binaries in Rust. I'm running out of time, I better hurry up. Yeah, you can create static binaries in Rust as well. It's if you can't if you just use normal compilation, those images will probably work with a glibc dynamic image and use the glibc in there. But you can also use the muzzle target, which will create a completely static image. Where's my notes gone? There we go. Distroless, I can't remember if I mentioned that before, but Chainguard images are often described as distroless. So like our static image, but also like our runtime images, like a JRE image, are designed to contain the minimum number of dependencies required for the application. They don't even have a shell or package manager by default. And that's what you mean by distroless. There are, however, latest -dev versions of most of our images, which do include a package manager and shell. Which brings us on to debugging that I'm going to move through quite quickly. Let me see if I can share my shell again. Here we go. So do I still have that running? So we still have this running. So the problem that you have is I can't do docker exec -it on this image. If I can come on sequence P. So this is like the way we've probably a lot of you have learned to debug stuff in Docker is to run exec-it. And sit and play around with the image, poke at it, change things, see if you can get it to work. But this tells me there's no bin/sh because there is no bin/sh in this image. There is no shell to start a debugging session with. So what do I do? Well, you can try the advice here, Docker debug. Now, I think with Docker debug, you might need a Docker desktop license. But I'll show you a free version in a minute. But if I run Docker debug on this, oops, that's not going to help. I don't know. Oh, there we go. So I've already downloaded. If you've run this now, you might have to download the sidecar container. Basically, it creates a sidecar container which actually has Nix inside it, which is a package manager, operating system, programming language. But in this case, it's interesting because it has a package manager which allows us to install debugging tools. it does actually have a whole bunch of debugging tools installed by default. So now I have a shell, and I can type PS. I can see my binary, that's the PID one, that's the main process within the container that we see running there. And we can run things like ping, etc. I think it has Vim in it already. If there was something you needed, you can type install and the package name. It doesn't need to be a Nix package name, but you can install whatever software. There's also a little bit of linting help, so I can run entry point, and it'll tell me, oh yeah, your entry point's fine. Okay, so what if you don't have Docker debug? There is cdebug. I think I've got a link in the slides at the end. But basically, I can run cdebug exec. Let's see if I get it right. Oh, jeez, why's that done that? I could have just edited that. Exec. I think in this case I will need -- privileged. Yeah, and that's immediately giving me a shell in there. So yes, if you don't have access to Docker debug, try cdebug, and yeah, works very similarly. The third thing to point out is if you're on Kubernetes, there is kubectl debug. And oops. And kubectl debug does a few different things, but one of the things it does is allow you to start an ephemeral container attached to the pod, which is basically the same thing that cdebug and Docker debug do. There are a few gotchas in all these. I do have a blog post on the various differences in a video if you're interested. But that's the end of the practical. So I'll go quickly back to slides. I think I'll try and get to the end and then I'll go back to any questions that are left. Where's my... Yeah, so when you're debugging distros containers, yeah, be aware that there may be a -dev variant available. And if you can use the -dev variant, in development or in a test environment, you'll be able to add your own testing tools, etc. If not, try Docker debug or cdebug, or I've written ephemeral containers. I think I meant kubectl debug. Yeah, so just to go back to Chainguard and how our images have less CVEs. There's three main things, or four I've put here. We cut down on dependencies, so have as little as possible in our image. We saw we got to 0 dependencies in end in our example by using the static image and getting rid of that Git package. We keep things up to date. That's honestly the major thing we do in Chainguard. It's just we're constantly keeping everything up to date with the latest releases from the projects. We will apply patches when necessary, and we will also issue security advisories to say, yeah, that's a false positive, etc. Yeah, and to wrap up, it should be simple to change the Chainguard images in the vast majority of cases. We saw a very simple example there where I just changed the from line and nothing else needed to change. And there can be major advantages in both size and security. We do have a huge number of images now, over 1,200. And there are dev variants for most things and a whole bunch of FIPS images as well. There will be, I think we're making these slides available, and I got a few links here. So this one is the one on statically linking Go. Will tell you more about how to create static Go binaries going beyond just cgo enabled equals 0. We've got a link to cdebug, Docker debug, and also our Academy guides and our images. Okay, let me jump back to the questions. Oh, thank you, Lisa, for sharing the blog post. Best practices for handling init process-based dependencies. Yeah, Tinny's good. The PID exhaustion pitfall, did you hit that? So you had like zombie processes. That sounds like honestly, like if you got PID exhaustion, I worry about the application. Yeah, we do have tinny. I think, do some of our images include it by default? But yeah, you can, if you're creating your own images, you can definitely add that. I think there's a few other ones. I can't remember which other ones we sometimes use, but tinny is great. For those that aren't aware, tinny is basically a process manager. So instead of directly running your process, you run it inside tinny, which can help in a couple of situations where your process perhaps doesn't correctly handle system calls, or it doesn't correctly handle reaping zombie children. Okay. Yeah, please let me know if there's any other questions. Otherwise, I'll wrap up. Yeah, signal handling is interesting, and it gets even more interesting when you're PID 0, to be fair. So yeah, definitely use this for tinny. Okay. Yeah, here comes Lisa. I was about to say, do we have any last words?
No last words. Thank you so much, Adrian, and thank you so much for all the great discussion. I just want to share again that tomorrow there is a conversation about beyond golden images, how to build secure container images at scale, which I think will answer some of those questions you had in greater depth. So Adrian is going to be speaking with two of our internal engineers, RJ and Jamin, and it's going to be at this time, 1 p.m. Eastern tomorrow. So thanks everybody again for coming. We will share the recording of this on our website, and you will also get an email for this if you signed up. So if anybody, if you have colleagues or something that want to attend, you could also have them sign up or share the link with them when this is all set. So thank you. Thanks, Adrian.
Yep, those are great questions. So thank you all. Bye. Leave stage.